Welcome to day 84 of the school year. All right. So we have a total of 180 school days. We are on day 84. Now we have to think, is 84 prime or composite? Well, 84 is even, and the only even number that's prime is the number 2. So it is composite. And we need to do the prime factorization for both our denominator and our numerator. So let's see. 180 I could divide by 3. I can get 60 groups of 3 out of 180. Ends in a 0, so I can divide by 5. I can get 10 5s out of 60. That leaves a 10, so that would be 2 more. Yeah, I can divide by 3. I get 4. Divide by 2. I get 2. When I get to a prime number, I'm done. 84 is even, so that means 2 is a factor. Half of 80 is 40. Half of 4 is 2. 42 is still even. I can divide by 2. Half of 40 is 20. Half of 2 is 1. 21, I can divide by 3, and I get 7. 7's prime, so we are done. Let's go ahead and get down our prime factorization from least to greatest. 2 times 2 times 3 times 3 times 5, and 2 times 2 times 3 times 7. So let's see what we have in common, which looks like 2 times 2 times 3. 2 times 2 is 4 times 3 is 12. That leaves a 7 in the numerator and a 15 in the denominator. So let's go ahead and make our groups of 12. Your groups of 12 do not have to look like mine, but please make sure you keep your shaded separated from your unshaded, and you have 12 in each group. So I'm using different factors to make these, basically these little arrays. 3 times 4 is 12, 2 times 6 is 12. Alright, so let's count up our total groups of 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. 15 total groups. I have 1, 2, 3, 4, 5, 6, 7 shaded in. Alright, now that we've done our division with our model, let's go ahead and use our algorithm. Dividing 180 into groups of 12 and 84 into groups of 12. So I'm going to start with 10 times 12, because that just moves everything over a place and puts a placeholder on it, because each place is 10 times greater. Numbers the same, 0's a game, more on top, no need to stop. Numbers the same, 0's a game. Bring the 60 up here. And then 5 times 12 is 60. Numbers the same, 0's the game. 10 plus 5 is 15. Here, 5 times 12 is 60. More on top, no need to stop. More on top, no need to stop. And then 2 times 12 is 24. Numbers the same, 0's the game. 5 plus 2 is 7. Now we need to check using those inverse operations. The inverse of multiplying is dividing. The inverse of subtracting is adding. So to do the inverse of the division, I'm going to do the divisor times the quotient. And then to do the inverse of the subtraction, I would add the remainder. Divisor times quotient plus remainder. But since the remainder is 0 for both, and the identity property of addition says when you add 0 it stays the same, I don't need to actually add 0. So here I'm multiplying 2-digit by 2-digit. Be careful, it's not just 2 times 5 and 1 times 1. You need to do the 2 groups of 10 here and the 10 groups of 5 as well. So 2 times 5 is 10. 2 times 1 group of 10 is 2 groups of 10 plus 1 more is 3. Now I'm done multiplying by the 2. So now I'm going to multiply by the 10. Placeholder moves it over a place. 1 group of 5 is 5. 1 group of 1 is 1. Add these partial products together. I get 0, 8, 1. Here, instead of writing it as 7 times 12, I can use the commutative property of multiplication. 7 groups of 12 is 14. 7 groups of 110 is 7 tenths, plus 1 more is 8. So 84, that matches my dividend, check. 180, that matches my dividend, so check. So my numerator is definitely 7, and my denominator is definitely 15. All right, now let's go ahead and fill in our data collection page. Trimester 2, week 5. Today's date is 12/13/19. And our fraction for today is 7/15. Okay, so we did groups of 12. Let's go ahead and get out our number line. Last one we have is 4/15. So 5/15 is equivalent to 4/12, which is equivalent to 3/9, which is equivalent to 1/3, the simplest form. It's also equivalent to 6/18, 10/30, 12/36, 15/45, 20/60, and 30/90, as well as the beginning fraction. 6/15 is equivalent to 2/5. That's our simplest form. It's also equivalent to 8/20, 12/30, 18/45, 36/90, and our beginning fraction. And then today we have 7/15. So there is no line below it because this is our equivalent fraction in lowest terms, or simplest form. But we do have an equivalent fraction in the 6s, in the 4s, in the 3s, and the 2s, because 2, 3, 4, and 6 are all common factors, but 12 is our greatest common factor. All right, go ahead and put your number line away, erase your worksheet, and thank you for joining me.